Okay, this tutorial will help you complete the questions on homework number 9. So let's get started. The first box here has actually 12 equations that you're asked to solve. So there isn't enough space to show your work underneath these questions, so you're going to show your work in each of these boxes down below. So for this video, I'll just work out each question in these boxes here, and then I'll clear the screen. So question number 1. 6m plus 10 equals 4m. So copy the question down in this box right here. So what's most important when you begin is for you to understand that there are 2 terms on the left and only 1 term on the right. So the left side has more terms. When a side has more terms, you have to choose one of these if they're unalike that you're going to move to the other side. You use an inverse operation and a property of equality in order to do that. Since the right side has a variable, then that means I want to choose the term that has the variable to be moved. So to get rid of this 6m, I'm going to subtract 6m on both sides. This is called the subtraction property of equality. When I do that and I rewrite the problem, I get 10 is equal to negative 2m. Now I have a constant on the left and a variable term on the right, so I'm ready to use my multiplicative inverse, or divide both sides by negative 2. My final answer is m is equal to negative 5. You can write your answer in this way, or you could reverse it if you're more comfortable, and you can write your variable first and your answer second. Number 2, 18x equals 36 plus 6x. So again, my right side this time has more terms. So I have to choose one of these to do the inverse of. The one I choose depends on what's on the other side. If the other side has a variable, then I'm going to move the term with the variable. I'm going to subtract 6x from both sides using a property of equality, and then when I rewrite, I get 12x is equal to 36. Now I'm going to get rid of this coefficient here of timesing by 12 by dividing both sides by 12. X is equal to 3. Number 3, 9d minus 13 is equal to 8d. The left side has more terms, so I'm going to subtract the variable term since the right side has a variable term. Bring down my constant, bring down my equal sign, and combine like terms. 8d minus 9d is negative 1d. Divide both sides by negative 1, and I get my final answer, positive 13. Okay, let's do the next row of 3 questions. Number 4, t minus 15 is equal to 4t. You notice that I'm curving my letter t's here so that they don't look like plus signs. I don't want to get confused. The left side has more terms, the right side has a variable, so I'm going to use the inverse of the variable. Negative 15 is equal to 3t. Divide by my coefficient. Remember, the coefficient is the number that multiplies the variable, not the number on the left side. The coefficient can be wherever the variable is. I'm going to divide by 3, and I get negative 5. Question number 5. 9p minus 4 equals 7p plus 6. Now for this question, you'll notice that the left side has 2 terms, and the right side has 2 terms. So there isn't a side that has more terms. So which one do you choose? And the answer is any one that you want. You can do minus 9p on both sides. You can do plus 4 on both sides. You could do minus 7p on both sides. You could do minus 6 on both sides. The choice is yours. I usually recommend that you start with a variable term so that you can find out if it's going to disappear on you or not. I'm going to choose to subtract 7p this time because 7 is smaller, and if I subtract a smaller number, it keeps my variable positive. So I rewrite everything that I didn't use. This went away because it's an additive inverse. So now I'm going to add 4 to both sides and rewrite my terms and then divide by my coefficient. So P is equal to 5. All right, let's take a look at number 6. 10W minus 5 is equal to 7W plus 31. So the same thing as the last problem. We have a variable and a constant on the left, a variable and a constant on the right. The choice is yours on which one you want to move. I'm going to subtract the 7W to keep my W positive. 3W minus 5 equals 31. I'm going to add 5 to both sides. 3W is equal to 36. And divide both sides by my coefficient. So W is equal to 12. So pause this now if you need to look at the work a little bit longer as you work out your own questions. I'm going to move on now to question number 7. 16 minus 7h equals h plus 4. So this is actually a 1h, right? You can fill that coefficient in if you need to. So I'm going to add 7h to both sides because this is my lower variable. So 16 is equal to 1h plus 7h is 8h plus 4. I'm going to subtract 4 from both sides, and I'm going to get 12 is equal to 8h. I'm going to divide by my coefficient, which is 8. And if you're unsure what 12 divided by 8 is, that's when you take your calculator out. Do 12 divided by 8 is equal to 1.5, right? You can use a calculator on every question, on every lesson. So don't be afraid to take it out and use it. All right, let's do number 8. 8 minus 3f is equal to f minus 4. 1f, negative 3f. So this is my smaller number. Negative 3 is smaller. So I'm going to add 3f to both sides. And 3f's plus 1f is 4f. And now I'm going to move this constant. And I get 12 is equal to 4f. And now I'm going to divide by my coefficient. So f is equal to 3. Okay, last one for this row. We're going to do number 9. So negative 12y plus 15 is equal to 9y minus 6. Let's see. I have a 9y and a negative 12y, so I'm going to add 12y to both sides. Let's see. This one's going to cancel out. I get 15. 12y plus 9y is 21y. Now I'm going to add 6 to both sides. Whoops. Where did that go? Add 6. And I get 21 is equal to 21y. Oh no, my marker's acting really funny. Divide both sides by 21. And I get y is equal to 1. That was rough, but I think you get the idea. All right, pause the video if you need to look at these examples a little bit longer. I'm going to move on to the last row. So number 10. 4x minus 24 equals negative 6x plus 16. So I have a 4x and a minus 6x, or a negative 6x. So this is my smaller variable term, so I'm going to do the inverse of this to keep my variable positive. 10x minus 24 equals 16. Now I'm going to add 24 to both sides, and I get 10x is equal to 20, 30, 40. Divide by my coefficient, and voila. Okay, number 11. 1.4a minus 78 equals 4a. Not a big fan of decimals, but that's okay because I got my calculator here to help me. So, looks like my left side has more pieces, right? More terms over here. And my right side has a variable, so that means I need to use the inverse of my variable. So I'm going to subtract 1.4 from both sides, and I'm going to use my calculator just to make sure I get it right. So 4 minus 1.4. And I get 2.6. So negative 78 equals 2.6a. Divide by my coefficient here, 2.6. And now I got to use my calculator again. So negative 78 divided by 2.6. Oh, that wasn't so bad. A is equal to negative 30. Okay, last one. Number 12. 12.6 minus 1v equals 5v. So the left side has more terms, so I'm going to move my variable and get 12.6 equals 6v. Divide both sides by 6. And I'm pretty sure this is going to be 2.1, right? So what do we have here? 12.6 divided by 6, 2.1. Alright, so pause the video if you need to look at these a little bit longer. Otherwise, let's turn to the back side of the worksheet. So number 13 asks you to graph the following linear equation using the slope and y-intercept. So the slope is the coefficient of x, so the slope is 1/4. Right? That means you have a rise of 1 and a run of 4. And the y-intercept is the constant here. That's the y-intercept, or the number value that your point will be on the y-axis. So we like to start graphing at the y-intercept, which is negative 9, which is right, 1, 2, 3, 4, 5, 6, 7, 8, negative 9 right here. And from this point, I can draw more points by following the directions of the slope, which are to rise 1 and run 3. So let's see. If I rise 1 and run 1, 2, 3, I would be here. Rise 1, run 1, 2, 3. That would be right here. Rise 1, run 1, 2, 3. Rise 1, run 1, 2, 3. And I put arrows on both ends. Oh, what am I doing? It says the slope is 1/4. I was counting wrong. So I have a rise of 1, but a run of 4. So I'm going to start back here at negative 9. I'm going to count properly this time. Rise 1, run 1, 2, 3, 4. That's where I put my point. Rise 1, run 1, 2, 3, 4. Now you don't have to put all these loops in here like I just did. You can simply make your points like this. Rise 1, 1, 2, 3, 4. Count over. Rise 1, 1, 2, 3, 4. Rise 1, run 2. I run out of space. So I connect my points. I put arrows. And I label it with the name of the equation. Alright, number 14. My y-intercept is 4, so I start up here at positive 4. And my slope is negative 3. But remember, slope is a rise and a run. So if you don't have a number down here in the denominator, you have to fill in an invisible one. So my rise is actually negative this time. So I'm going to go down. Down 1, down 2, down 3. And then I'm going to run positive 1. You see that? That's positive, so that's to the right. So I went down 3, 1 to the right, and draw a point. Down 3, 1 to the right. Down 3, 1 to the right. Down 3, 1 to the right. And I pretty much like to keep going until I run out of space. Now sometimes, when you plot your y-intercept, it's so close to the edge of the graph that you can't even make one more point. So if that ever happens to you, you can take your slope and you can reverse both the signs for the numerator and denominator. So for us, that would make this one a positive 3 and that one a negative 1. So if I went back to my y-intercept, instead of going down 3, I could go up 3, but then I would have to go 1 to the left. So 3 up, 1 to the left. You'll notice I'm still on the same line, it's just the other half. Well, that was a little crooked, but make your line a little better than I did. And then we're going to label our line, y equals negative 3x plus 4. And then we're done. All right, the last question asks you to calculate the rate of change. So it says to use the graph shown here to the right that shows the elevation above sea level as measured over a 60-minute hike shown. So it looks like we have pieces here that are linear, and we can calculate the rate of change. So you can calculate the rate of change from points, like say you have this point here, which is the point 10, 5. 10 minutes, 5 feet above sea level. And you have another point here that we could call 20, 10, right? So if I ask you to find the rate of change from 10 minutes to 20 minutes, then we could use these 2 points. So the points are 20 and 10 and 10 and 5. It doesn't matter which point comes first, but these are our x's and our y's. So the formula says to subtract the y values and then subtract the x values. So the y values are 10 minus 5 and 20 minus 10 for the x's, right? These are the y's and these are the x's. So 10 minus 5 is 5 and 20 minus 10 is 10, and that reduces to 1/2, right? So let's count this by using rise over run, which is something we can use only when we have a graph, which we actually do have a graph. So it looks like if I start here at 10 minutes and I want to calculate the rate of change to 20 minutes, that I'm going to rise up 1 box, but that's actually 5 feet. You get that? So I know it's only 1 box, but it's actually a change of 5 feet. And then my run this way is 10. So that's where I get the 5 and the 10 from. 5 over 10. All right, let's take a look at number 16. Find the average rate of change from 20 minutes to 30 minutes. Well, we practiced this a long time, and you should know what a horizontal line has a slope of. But let's prove it mathematically. So we can use points, or we can count rise and run. It looks like my rise is 0, and my run is 10. So it looks like I'm probably going to get a result of 0 divided by 10, which is 0. But let's use our points to double check. So my first point here is 20 on my x and 10 on my y. And my second point here is going to be 30 on my x and 10 on my y. So I've got 30 and 10 and 20 and 10. And these are my y's, right? Y minus y. So 10 minus 10 over 30 minus 20. And sure enough, I get exactly what I got when I counted my rise and run. A horizontal line has a slope that is 0 fun, right? 0 fun. All right, the last question. Change from 40 minutes to 50 minutes. So 40 minutes has an elevation of 5 feet, and 50 minutes has an elevation of 25 feet. So if I want to use my formula, I would do y minus y. And if I start down here with the 25, I have to start down here with the 50. And x minus x. Well, 25 minus 5 is 20, and 50 minus 40 is 10. And that looks like a rate of change of 2 feet per minute, right? Because the y is feet and the x is minutes. So this is 1 foot per 2 minutes, and this is 0 feet per minute, and this is 2 feet per minute. All right, let's see, count our rise and run here. 5, 10, 15, 20, 20 over 10. And that's the video that will show you how to complete homework number 9.